Alright, here we go with a new video where we're installing the thermodynamic water heater. And here's something new. I'm no longer running the water supply through the crawl space, I'm going through the attic. It's right here. I said I wanted to go into the crawl space, cut the PE pipe, add a fitting, and bring a small PE pipe back up. The PE pipe runs from the street, through the crawl space, and into the house. In the closet where I swapped a broken 300-liter unit for a slim 80-liter one. I told you I wanted to clear this closet, remove the 80-liter unit, and move it upstairs for a future bathroom. I'll run the water supply and connect to the attic water line. All attic spaces and sloped ceilings will be insulated, and areas under 1.8 meters will serve as a technical gallery. There will be ventilation, electricity, drains, water, etc. I unrolled the multi-layer pipe at once so I can tap into it later for the bathroom. It comes back down here, of course. We connect it to the PE pipe, and in the closet there will be the PE pipe, a valve, a backflow preventer, and a water meter. So the thermodynamic water heater will supply the bathroom, a kitchen sink, a hand basin, a toilet, and another bathroom, and the famous extra flat 80-liter one will go upstairs for another bathroom. So the upstairs bathroom will be independent and it will supply the rest of the house. I'll start by placing 2 clamps for the water supply from the ceiling. This will apply to the whole installation. I'm offsetting the clamps from the partition and back drywall, so I'm using expansion anchors that I'll crush. Threaded rod in 8 mm or 10 mm, and 8 is more than enough, whether it's 8 or 10. It fits into this type of clamp, we screw it in, and so we end up with the clamp, the threaded rod, and I screw everything into the expansion anchor. And the advantage, as you understand, is that the clamp is offset from the drywall. The benefit of doing this is that if one day I need to repaint this room, instead of bothering with a brush to go around the rosettes to make between the pipe and the wall, with my small brush, I can use a roller. So depending on the length of the threaded rod, you can use a roller or a paint pad. Mine are 10 cm long, so a paint pad is ideal, but I could use a roller for longer ones. So clamp, threaded rod, anchors, expansion. So, did you see there are blue tapes? That's to mark the studs, to avoid drilling into a stud, because crushing an expansion anchor into a stud is going to be complicated. So at least here, I know where to drill. For the water supply, I unrolled a 26 mm GB Ritme multi-layer pipe in the attic. It's flat, very rigid, but unrolls easily and installs in one go. I bent it at ceiling height so it drops into the room without fittings between the ceiling and future floor. If you need to install a fitting, make sure to put an access hatch at your ceiling. Your fitting must be accessible. We can continue. I'm installing a shut-off valve at the GB Ritme, where the fitting is flat and connecting my valve. And for sealing the fittings, Tangent Unilock is a nylon thread impregnated with silicone. It replaces hemp. I don't need joint paste. It's easy to install, clean, removable, and withstands up to 7 bars and 130 degrees. It's for cold water, hot water, and gas circuits. I've set up the workbench and vise. I'll put some fittings in the vise, apply Tangent Unilock, and continue. The goal is to install a valve and the pressure reducer. We'll need to make it watertight. When it comes to fittings, you can see the difference between a fitting that isn't notched and a notched fitting. This is the Rhythmic fitting. It's for the flat part in 26 mm diameter. They're already notched by default, but this one isn't notched. We're going to notch it with this type of pliers or with a hacksaw, a utility knife blade, whatever works. This type of pliers can be adjusted depending on the fittings. You position it, tighten it a little, and turn it around, and that will notch it. Now that it's notched, it really looks like the other one. I can apply my sealant. The Unilock and the thread won't spin around. If I don't notch the fitting and just wrap the thread, tightening it might cause the thread to slip. Now, it's really going to catch in the threads. With the fittings notched, we can seal them using Unilock Tangite. I take the nylon thread, hold it with my finger, and wrap it around the threads. With the nylon thread, we cover each thread. Mark the required number of turns on the box. You need to apply a certain amount of tension. It should look like this. We're doing well. Once we're done, we cut it. We roll it up. And with your finger, you press everything down. And you end up with this. With a watertight removable connection, and it's pretty clean. You see, I don't have grease all over my fingers. I sealed the electrical connections. I installed one on the safety group, always using Tangic Unilock. The safety group, it's the X-Cross model from Thermador or Caleffi. It's here with a special feature. You can switch between vertical and horizontal. Remove the clips, place the valve here, put the cap at the base, and I added this part, but it's optional. See, for my expansion tank, I connect directly to the safety group, a traditional safety group. I would need to add a T-joint to connect for an expansion tank. Here, we connect directly with O-rings like on the cap, so everything's newly sealed. We're good. As mentioned, it also has a horizontal-vertical feature. In this diagram, the water heater is shown with the supply entering from the top, the expansion tank on the side, and the siphon below. In my case, it's going to be like this: the water heater, the water supply, the expansion tank, and the siphon. But of course, the water supply could also come from underneath. We turn it so the siphon faces down, the expansion tank, the water heater, or the other way around: water heater, water supply, expansion tank, and the siphon. So the next step is to install the faucet for the toilet. I remove the hatch, I drop this part. The faucet looks like this, so you can't install it wrong. It must be installed this way. See the shape? If you do it differently, it won't work. So we install it this way, from behind, there we go, we put it in. We take the ring and tighten it. So for this one, it's done. We put the hatch back and move to the other side. So to supply the frame with water, the multi-layer pipe, I prepared my fittings at 20 millimeters in diameter. I had already bent it. When I was working on the copper installation, I made a template for the future fittings. I need to cut it here, so we're going to cut it. With the pizza cutter, it looks like a pizza cutter, but it's actually a pipe cutter. We cut, we deburr, we calibrate it, then we position the fittings. And I just put this piece of pipe to supply copper up to the frame. Hold it briefly, turn the pipe to avoid crushing it, and that's it. So the cut is pretty clean, but well, just because the cut is clean doesn't mean we won't. Calibrate it, bevel it, there we go, let's do it. Turn it to the other side, I had already done it. Now it's calibrated and beveled. I can attach my fitting without damaging the seal. Previously, we installed the faucet in the frame. Now we can add the magic fitting. It's tightened only by hand. We don't add any sealant. The O-ring is inside. So, as I said, no pliers, no wrench, just tighten it by hand. And then we can put in our pipe. We've made significant progress with the installation. I'll stop here. I'll install 2 valves for now, since I'm supposed to connect to the drain. Bring a drain up to here, a cold water supply for a future washing machine. I'd also like to install a large white basin for washing buckets and tools like we had in the past, since I have hot and cold water. No matter, but for now I need to do the insulation, put up the drywall, and especially make my sliding door, which should be around here. And I'm writing it here door since I need to open the ceiling to access the attic. Cutting through solid materials will generate dust, cold, noise, all that stuff, so a sliding door is a must, and it's going to be an ultra-light door. Nothing complicated, I'll explain soon. I also need to mention the holes I made in the facade on the neighbor's side and that I wasn't going to set up all my equipment. I said, wait, I'm making a video at your place, and quickly filmed it. I'll explain in the next video. So what do we have? We have a water supply, we lay it flat, diameter 26, there we go. It runs here, a pressure reducer valve, a bypass for a future water softener. Here, with the valve open, city water flows this way. If I close the valve, water takes this path. When the valve is open, water goes through the softener filter and is softened. Over there, I bent the pipe. Here, I modified it and added a valve. There's another one below. So this valve allows me to shut off the water supply to the water heater. So I shut off the water supply to the water heater. This lets me drain the entire system of water heater since I'm at the installation's lowest point. I remove the cap, attach a Gardena connector and hose to the rainwater collector, open the valve and drain the system or just the water heater, recovering at least 300 liters instead of wasting it. The white polyvinyl chloride is what I bought for a client and I never used it. So now I'm using it for the safety group. At least this way the bar disappears, we don't talk about it anymore. The expansion tank comes with a flexible hose, but the best thing is to bend a copper pipe yourself, and at least it holds better, because here the clamp has been redone. Honestly, it's not that it's great, but it does the job. It would be better if they welded brackets onto the expansion tanks for us to make them sturdier, but otherwise a bent copper pipe works. So the water supply continues, the toilet, the sink, we go up into the attic, and as I said, we end up here for the washing machine and the future basin. Cold water supply, hot water supply, and so for the hot water we have the cold water feeding the water heater. It comes out here with a valve. I shut off the hot water, then the sink, and we go up into the attic and of course the hot water supply up to here. So for now the installation has gone pretty well. We're going to head up into the attic. That'll be the next step. So we're going to install the manifolds. You understood that originally I wanted to install them here, but in the end it's completely pointless. I'll have to bring up at least 4 cold water lines and 3 hot water lines. Might as well run 2 pipes up and then distribute them from the attic. It's much simpler. So what you need to do on part of the installation is leave the markings visible on at least 1 pipe so it's easy to see. Now with copper, honestly, it's just copper. It doesn't really matter, you just measure it with a caliper. We know if it's 16, 18, 22, 28, whatever. But here, for example, we have the brand, although there's not much left on the pipe. It's 22 the standard. The date shows it was made on March 4th, 2022 at 6 o'clock. Anyway, you have all the markings on copper, like I told you, engraved, but on multi-layer pipes, it's really important to do it. Not on the whole installation, but on a visible part like here. I can see this one clearly. It's flat Chiberitme. Everything is clear. Why do I do this? Suppose I sell the house tomorrow. The new owner wants to change something, calls a plumber, and the plumber arrives and wonders, what is this pipe? I have absolutely no idea. I've never seen this in my life. He'll be glad to know it's flat Giberitme, 20 millimeters in diameter. So he tells his supplier he needs flat Giberitme fittings, 20 millimeters, and can fix it. So, for those who are wondering why I put the copper pipes at this height, well, simply because I can stand on both sides and do my exercises. You see, it's pretty convenient. Or the hot water goes through the pipe gets hot, I put my wet socks, wet clothes on it, and it dries. It works as a drying rack. I'm tired of working uncomfortably close to the ground or with my arms up. I want it to be comfortable. It's just a utility room, so it doesn't matter. You put the pipes at the right height, the height that suits you, and it'll be perfect. I can even close this off here, put a door here for the washing machine, make something much neater with the pipes. If they have to be exposed at floor level or higher up, or even hidden, and here in the utility room, it really doesn't matter at all. Next, we'll run the pipes, install the manifolds, and reroute cold and hot water for the shower, bathtub, and the washing machine going in the closet behind the tub. As I explained in earlier episodes, we're now going up to the attic. We also have to connect the bathtub and shower drains, so we'll go back into the crawl space, but this will be the last time. Well, in any case, I really want to thank you for watching this video. We'll meet again very soon for the next part of the work. In the meantime, take care and see you very soon.